3.8 is Newton's method, and Newton's method is a process, a recursive process to find the zeros of an estimated zero of a function. And if I have time at the end of this video, I will definitely go back and talk more about Newton's method. But since we have graphing calculators to find our zero, we really don't need to use Newton's method anymore. Instead, we're going to address the idea of using tangent lines to find values on our function. So we've used tangent lines to find the instantaneous rate of change of a function at a specific point, and now we're going to use some other uses of these lines. So, number one, the graph of f of x is shown. Go ahead and pause the video and do your best to just sketch your tangent line at x equals 3. Well, there's my tangent line at x equals 3. And on number two, the equation of that tangent line I'm giving you at f of x when x is 3 is y minus 1 equals negative 1.75 times x minus 3. So what information do we get from this line about the graph of f of x? Well, think about what you need to be able to write a tangent line. In order to write a tangent line, you need a point and a slope. So therefore, this equation is giving you the point and the slope. So again, pause the video and write down the point and the slope that this line gives you. So remembering point-slope form of the line, we can determine that our point is 3, 1, and my slope at 3, so f prime of 3, is negative 1.75. So number 3, we don't have enough information to find f of 3.1, but can we estimate it? So will f of 3.1, will that be greater or less than f of 3? And how do you know? Well, f of 3.1 is down on this side, right? So if this tangent line is sloping down, it's below that my actual function. So it's going to be less than, because the graph, or f of x, is decreasing at x equals 3. Now I'd like you to pause the video and approximate f of 3.1 by plugging 3.1 into your tangent line equation. And then we kind of have already answered letter C, but go ahead and write down your answer for that. Is your approximation an overestimate or an underestimate of 3.1? And how do you know? When I plug in 3.1, I get that the value would be 0.825. And so the 0.31 is right here. And if I think about it being on that tangent line, then 3.1 is going to be down a little farther, so it's going to be 0.825. So now, for which values of x do you think the tangent line at x equals 3 does a good job of approximating the function value, and why? Again, go ahead and pause the video and write down your answer. So at the point x equals 3, the tangent line and the function have the exact same value. So any value that's super close to 3 is going to have a good estimate, and that's because the tangent line is closest to the actual function at x equals 3. Number 5, find an x value on the graph of f of x where the tangent line approximation gives an overestimate of the true function value. If we go ahead and look at this function up here, when x equals 0, if I draw this tangent line, so at x equals 0, I can figure out what the slope would be. If I come a little bit above that and I go up to that tangent line, that's going to be an overestimate. If I were to come a little bit below 0, and I were to use that tangent line approximation, that's going to be a bit overestimate. So I could say that at x equals 0 and at x equals even 1, right? Anytime that the tangent line is going to be above or on the outside of that graph. Where would the tangent line approximation give an underestimate? Other than at x equals 3, where else might it give an underestimate? Well, again, anywhere that the tangent line is below. So if I were to find this tangent line at x equals 5. If I were to go a little bit above 5, here's the actual value, right? But my tangent line is below that, so it's going to be an underestimate. And so there we have those two answers for 4 and 5, and the reason. The tangent line being above or below the graph is going to tell you whether the tangent line approximation is going to be an overestimate or an underestimate. On the next page now, I'd like you to, again, pause the video and try to do that number 7. You're basically doing number 7 what we just did in number 3 above. So from the equation, or from the information given, f of 1 equals 4.5, I'm given the point, so 4.5, and then f prime of 1 is negative 0.75, so that's my slope. And now I can go ahead and write my equation, and then I can use my equation. There's my equation, and all I did was I brought that minus 4.5 over to the right-hand side because I'm going to be solving for y anyway, and so now let's go ahead and plug in 0.99 for my x. And you should have gotten 4.5075. So now let's talk about these important ideas for this section. The big overarching idea is that tangent lines can be used to approximate actual function values near the point of tangency. Graphically, this is what we're saying. For any x values near x equals a, the tangent line L of x is approximating the function value f of x. Realize also that if the graph is concave up, then L of x is going to give, the tangent line is going to give an underestimate because it's going to be too low. If I pick a value over here or here, this value is going to be lower than the value on the graph. If it's concave down, if we were to look at this side of the graph, then any value L of x is going to be an overestimate. It's above the curve, so it's going to be an overestimate of what that actual function value is. All right, let's do 3 problems or 4 problems and see if we got this. Let f of x be a function with f of 2 equals negative 6, and the slope of f at any point xy on that function is given by f of x over y squared. Write the equation of the line tangent to f at x equals 2 and use it to estimate f of 1.8. So we have to write the equation before we can actually use it. So again, think about writing the equation. What do we need? Can you go ahead and write down what the slope and what the point is that we're going to be using? And if you've got those, then go ahead and write your tangent line. So just like with related rates, I'm going to go ahead and write down what I know. I know that f prime of x, the slope of f at any point, is 5x over y squared, and f of 2 equals negative 6. That's the information that was given to me in the problem. So I'm given an x and a y. I can plug those into my slope, and I find that my slope is 5/18. My point is 2, negative 6. So then I can write my equation. I've done part 1. Now I'm going to use my equation to estimate what is f of 1.8. So go ahead and do that. So all I did with this step was I plugged in the 1.8 for x, and I brought that positive 6 over to the right-hand side, subtracted it so it became a minus 6. And there I have that f of 1.8 is negative 6.056. Number 2. Let g of x equals 3 sine x plus 1. Use the tangent line to g of x at x equals pi over 2 to approximate g of 1.5. You're basically going to be doing the exact same process that we did above, so go ahead and pause the video and do part A, please. I need a point, so the first thing I did was I plugged pi over 2 into my function so I could get a y-coordinate. So my point is pi over 2 and 4. Now we need to take the derivative of g of x so that we can find the slope at pi over 2. Finding the derivative, I get that my slope is 0, so now I can write my equation. Y minus my y-coordinate equals my slope times x minus my x-coordinate. So I get y minus 4 equals 0, y equals 4. Now use your calculator. We have our function, so use your calculator to evaluate g of 1.5. G of 1.5 is 3 times the sine of 1.5 plus 1. Again, make sure your calculator's in radian mode, but go ahead and put that into your calculator, and you should get that you've 3.99248. So how far off was our approximation from the true value in part A? So 4 minus the 3.99248. Pop that into your handy-dandy calculator. Our estimate was pretty darn close, 0.00752. So less than 8 1/1000ths off. Our tangent line approximation gave us a pretty darn close estimate. We've talked about this one a few times, so go ahead and again pause the video after we're done reading this. Sketch a graph of a function where the tangent line approximation at x equals 1 will be an underestimate of the actual function value near x equals 1. Well, remember, to be an underestimate, first of all, let's put our 1 there. Remember, to be an underestimate, the tangent line needs to be below the actual graph. So if I were to just graph some sort of curve, this tangent line, any point, right, if I want to find that approximation, the approximation is going to be slightly lower than the actual function. So that would be my graph. And number 4, multiple choice. Let h be differentiable on a function such that h of 4 equals 3. So we're given a point, and h prime of 4 is negative 2. If the tangent line to h of x at x equals 4 is used to approximate the zeros of h of x, then the approximation is which of those 4 values? So we're using a tangent line approximation, so let's go ahead and write our tangent line. We have our point of 4, 3, and our slope at 4, h prime of 4, is negative 2. So y minus 3 equals negative 2, x minus 4. And then the key here is we're approximating the zeros. So basically that means my y is 0. So 0 minus 3 equals negative 2x minus 4. And we just have to solve this for x. So 3 halves is 1.5. So x was 5.5. If you have any questions, please make sure to write them down, and we will see you in class.